Hi folks, welcome to 10.3. Sorry we didn't get a chance to go over this in class today, but I think if you understand the 10.1 and 10.2, 10.3 is probably a little bit simpler than those two, okay? It does come with its own set of rules, so just like we had rules for ellipses and rules for hyperbolas, we do have to think about logic and rules that follow for parabolas, okay? So let's do a quick summary of what we know so far. We know that if we take a double napped cone and we slice it straight across, we will get a circle, okay? And we know that if we take a double napped cone and we slice it on the diagonal, we'll get an ellipse. And we also just learned that if we take a double napped cone and we slice it down both of them, we'll end up with a hyperbola, okay? And so let's think about what our equations tend to look like for this, all right? So our equations for the circle tend to be something like x minus h squared plus y minus k squared equals r squared, okay? Sometimes we see it that it looks like the ellipse, but the denominators are the same. So that's another way to think about it. But the ellipse is our x minus h squared over a squared plus y minus k squared over b squared equals 1, okay? And then last but not least, our hyperbola equation actually looks a lot like our ellipse equation, except we have a minus sign in between, okay? And don't forget that with the parabola, we could switch them, okay? So maybe sometimes the x comes first and sometimes the y is first, okay? And so that's gonna depend on the equation, and then the graph will look differently if x is first versus if y is first. So where are we now? What's new? Well, we're going to take a look at one last conic section. And this conic section is when we take a slice of the cone like this, where it's like the hyperbola, but we only go through one of the cone. And that, my friends, is what we have called a parabola, okay? All right, so that's where we're going visually. And before we take a look at parabolas, let's take a look at completing the square, okay? Now, what I want to do with this example is really help us understand what we're doing when we complete the square, okay? So I know I've said take your b value, cut it in half, so b equals 8. We cut it in half, we get 4, and then we square that to get a plus 16. Okay, so that's a process that we've learned. We take the b value, we cut it in half, we square it. And then we could write this as x plus 4 squared, okay? But what I wanted to talk about here is actually give you a visual on why we're doing this. Like, why are we cutting stuff in half? Why are we squaring something, okay? So let's start off with our area model. So if I just wanted us to draw x squared, you could draw a square and it has x, and that area is x squared, right? Well, what we have here is x squared plus 8x. So I don't want just x squared, I want x squared plus 8x. So one way of doing that is saying, well, I'm just going to add on to this one side plus 8, and then this will give me 8x, right? That's one way of adding 8x. But one of the things in math is the structure of the perfect square is actually really helpful. So if I wanted to make plus 8x, but I actually wanted us to keep it as close to a square as possible, here's our beginning square. And this is where we get the x squared from. But instead of adding 8 all the way to the right, what we're going to do is we're going to take, ready for this, half of 8 and add it here. And then half of 8 and add it here. So I think you would all buy that 8 is 4 plus 4. Or this box would be 4x, this one would be 4x, and that's equal to x squared plus 8x. So when we're thinking complete the square, the reason why we cut it in half is so that we can keep it as close to a square as possible. So complete the square literally means keep the area model as close to a square as possible. That's where we get the 4 from. We take 8, we cut it in half, we add half over here and half down here. Now, I think we would all agree that the shape we have right here, this is not a square yet, okay? So now let's think about where this plus 16 comes from. Well, if we extend this square and this one, the area of this piece that we're adding here is 4 times 4, or plus 16. This plus 16 is what we're adding here to make it the perfect square. But it's not really there. We just added it to make it a perfect square. And so what we have to do is, this is why we need to balance it. So we do minus 16 really takes this part, takes it away, and keeps the equation balanced. So we didn't actually change the original problem, okay? So this is just a quick little thing to help you maybe understand why we divide by 2 and why we square it, okay? So we divide by 2 to get the 4x, this half of it and this half of it, to get as close to a square as possible. And then that part that we subtract is the part that gets added when we square it, but wasn't really there in the beginning, so we have to sort of take it back away, okay? So hopefully this was helpful. If it was confusing, don't worry about it. You can still get by with the process, but for those of you who are maybe wondering why we cut it in half and why we square it, this is a little visual for why, okay? All right, so let's go ahead and move on to parabolas. So remember, for ellipses, I had a picture of Ernie and Bert, and that was kind of cute and fun. But then we looked at that video that showed us the table and like how we could cut a perfectly elliptical table using the definition of the ellipse, okay? And so one of the cool things about parabolas is that we actually use them quite a bit in like satellite dishes, or like if you've seen a sports game, there's someone on the sideline picking up all the sound with this parabolic dish, okay? And so what they use is actually the definition of a parabola to help them maximize the sound that they pick up. All right. And so if we were to think about just a 2-dimensional parabola, we could have one that faces up and down, up or down, okay? So let's say we had this parabola, a few vocab terms that we could put on here. This point right here, the turning point, we call that the vertex. Now, inside the vertex, or inside the parabola, there is a focus. So it's not foci, there's not more than one of them, there's just one focus. And there's one vertex. And then there's another feature, which is a line called the directrix. Now, in a directrix like this, the equation will be y equals a number, okay? But it turns out that we make a parabola by finding the same distance between the focus and the directrix and tracing that all around. That's how we get a parabola, okay? Now that distance specifically is actually what some folks asked about in class earlier. The distance from the focus to the vertex, that distance is p. And the distance from the vertex to the directrix is also p. Okay, so p stands for the distance between the focus and the vertex, or the vertex and the directrix. Okay. Well, those are our normal up and down parabolas, but sometimes we have parabolas that face sideways. And guess what? These parabolas have all the same features. We have a vertex, we have a focus, the distance from the vertex to the focus is still called p, and we have a directrix, and that equation is going to be x equals a number because it's a vertical line. And the distance from the vertex to the directrix is also p, okay? So that's sort of what we're gonna be drawing as we go along. We're gonna wanna find the vertex, find the focus, find the directrix, and then sketch all those features. Now, for those of you who are more equation-y folks, here's a list of all the equations that go with them, okay? So when we have our up and down parabolas, they're gonna follow this form. But when we have our side-to-side parabolas, what's gonna be different is the y squared for the right and left ones, whereas the x is squared for the up or down parabola, okay? So only one of them is squared for the parabola, and the one that is squared tells you whether it faces up and down or right and left. All right, let's get started on some practice. Now, I really like that as a whole, this class is pretty visual in wanting to sort of take the information from the equation, draw the picture, and then label all the stuff, and that's totally fine with me, okay? There's nothing wrong with that. So let's unpack this equation, okay? How do we know this is a parabola? Well, it's in the parabola section, but how would you know on a test or a quiz? Well, we've got a y and it's squared. So I actually automatically know that it's either going to be facing right or facing left. Okay, and that's because of the y squared. Now, if there's a negative sign in there, let's choose a different color. If there is a negative sign, it's actually going to open to the left. Okay, so if there's a negative p, it's going to open to the left. If there's a positive p, it will open to the right. All right, now what is our vertex? Let's start there. Okay, so the vertex is kind of like the center for the parabola. All right, now we want to choose the x value of the center first, so it's going to be -3, and then the y value of the center, which is 1. And that point we can go ahead and sketch on our graph -3, 1. Right, there's our vertex. Now to draw everything else, we do need to identify P. So let's go back up for a moment to the equation. So in the equation, we're going to notice a few important things. This number in front of the non-squared side is equal to 4p. So we can see the same thing over here. This coefficient in front is equal to 4p. So if we take that number and we divide by 4, we'll get p. All right, so what's our coefficient? 16 equals 4p. That means p equals 4. Okay. Now, I know there's a negative sign. You could take the negative sign with it. You could say -16 equals 4p and p equals -4. You can do that, and this negative sign will tell you to the left. Or you can do them separately where you've chosen from earlier it's going to be the left, and this is how far. Okay, so I'll leave that up to you whether you want to do those pieces of information together or consider them separately. All right. Now, once I have the vertex, I almost like to sketch the shape of my parabola. Okay. Oops, wrong way. We want to make sure it opens to the left. Okay. And now, once we've drawn that, we know our focus has to be like in here somewhere to the left of our vertex. And so if we think about that, what we're gonna do is we're gonna take this number we got for P, and that's how far we're going to count from the vertex. So from my vertex, I'm gonna go over 1, 2, 3, 4. That is where my focus is. And if I think about how I got that, I took the X value of my center and I subtracted the P value and I kept the Y value the same. So center or vertex, that stays, and then I subtracted the P value to find the focus. Now I subtracted it, you can think about it because it's negative, or you can say I need to subtract it because I know it faces to the left. And both ways are reasonable steps to take to drawing that, okay? Now, how do you find that directrix? Well, to find the directrix, you can count 4 points in the other direction. So 1, 2, 3, 4, and there's your directrix, okay? So we can see from here that this distance is 4, and this distance is 4. That's what P stands for. It tells you how far between the vertex and the focus, or the vertex and the directrix. Now, if we want to write an equation for that directrix, we would say x equals -3, which is from our center, plus 4, because we're going to the right. So plus 4, and then our -3 is from the center, because directrix is on the right. Okay? So the parabola is actually a little bit more straightforward than some of the other graphs that we've seen, just because there are less features to graph, okay? We need a center, or we need the vertex, we need the focus, and we need the directrix, and that's it, okay? All right, let's take a look at another example. X squared equals 8y. Well, I only see one square, so I know it's a parabola. And my choices for the parabola are up or down because it's an x squared, okay? Now, is this value positive or negative? Well, it's positive, so we're going to choose the up parabola, okay? Now, this one might almost look so simple that we don't know where the vertex is, but really, this x squared is like saying x minus 0 squared. And the y is really like y minus 0 squared. So our vertex in this case is actually right at the origin. Okay, let's find p. So we take the coefficient, 8, and that equals 4p. So in this case, p equals 2. That tells us how far we count up and down for our focus and directrix. Now I said earlier it faces up, so let's get that parabola in there facing up. Now to find my focus, should I add 2 or should I subtract 2? Well, if you think about it, we want our focus to be inside of our parabola, so in order to achieve that, we need to add 2. So 0 and then 0 plus 2. Okay. Center or vertex and P. Well then, how about we go ahead and draw in our directrix? We're going to go down 2 and we're going to draw a dotted line. How did we get that? Well, that's going to be y equals, whoops, y equals, let's see, all we did was go 0 minus 2. Okay, so we took our center or our vertex and we subtracted the p so we could get where the directrix is, y equals negative 2. Okay, so not so bad. You just got to remember that you have to take that coefficient, divide by 4, and that will get you the how far you need to go to find your focus and your directrix. Okay, so now let's layer on completing the square. Okay, so I know that when I look at this, it's going to be a parabola. And here's how I know. I know because I only see one squared, only the x is squared, all right? And the y's are there, but they're not squared. So one variable squared means it's not an ellipse, it's not a hyperbola, it has to be a parabola. So now let's talk about what completing the square looks like for a parabola. We're going to take our x's and we're going to group them. Okay, so that part is the same. However, we're going to move everything else to the other side, including the y. So that will give us x squared minus 8x equals 28y plus 208. Okay, now we have to complete the square on the left-hand side. So x squared minus 8x, let's see, half of negative 8 is negative 4. Negative 4 squared is plus 16. 28y plus 208 plus 16 to keep it balanced. Now we turn the left-hand side into x minus 4 squared. And we combine some like terms on the right-hand side to get 28y plus, what do we get here? 422. Okay. All right. Now we're almost done. We just need to factor out that 28. So 28y plus 8. Okay. And this right here is our completing the square. Okay, looks a little bit different for the parabola because we only have one variable that we need to complete the square for you. All right, so from here, let's find our vertex. Vertex is going to be 4, comma, -8. All right, let's put that on our graph. 4, comma, -8. All right, let's use our equation to find out p. So 28 is the coefficient, equals 4p. That means the distance from the focus to the vertex is 7. So let's look at our equation. X squared equals a 28, a positive 28. So x is the squared, so I know it's either up or down. And because 28 is positive, it's going to be facing up. All right, let's find our focus. From my center, I'm going to count up 7. Okay, so 2, 4, 6. There's my focus. So all I did was I kept the x value, and the y value, I added 7. All right, let's count down 7 for the directrix. 2, 4, 6, 7. All right. So we know it's a horizontal line, so y equals, and then we take -8 and we subtract that p-value. And we get a directrix at y equals -15. Okay? So there's that problem all on one page. But really, it's like, how do we know whether we count up or down or side to side? I really think drawing that picture and deciding in advance which direction it's facing will help you figure out where to add number, okay? Let's take a look at one more graphing before we move on to equation writing, all right? Threw in some fractions there because they're good practice. All right, so let's see. I only see 1 squared, so I know it's a parabola, okay? The y is squared. And so I can even say it's either going to be this way, pointing right, or pointing left. Those are my choices because the y is squared. And so what we're going to do is we are going to complete the square here. I'm just going to flip-flop the sides so my y squared is on the left-hand side and my x is on the right-hand side. And to kind of make my life a little easier, I'm actually going to take the entire equation and multiply by 2. So I'm going to get y squared plus 8y plus 22 equals 2x. Right? And you're allowed to do that. If you see a lot of fractions, if you multiply by that denominator, you'll get rid of a lot of the fractions and then you don't have to worry about that so much, okay? Now we can complete the square like before. I'm going to keep the y squared plus 8y. I'm going to move that 22 to the other side. Now our b value is 8. So 8 cut in half is 4. 4 squared is 16. Keep it balanced, plus 16. Write out your perfect square. Y plus 4 squared equals 2x minus 6. And then last but not least, we need to factor out that 2 and we get x minus 3. Okay. So this time, let's find p first, all right? We know that 2, or that coefficient, equals 4p. Now I wanted to do one where p is a fraction because I think sometimes we never do those problems, so then we think if it's a fraction, it's wrong, but it's not. okay? So we should get P equals 1/2. That means that from my vertex, I'm going to count side to side 1/2 to find my focus and my directrix. So what's my vertex? Well, the x coordinate is 3 and the y coordinate is -4. So let's graph that here. 3 and -4. Okay, there's my vertex. All right, now what did we decide earlier? Okay, we decided it's going to be either to the right or to the left. Now we have this is positive, so we're going to choose facing to the right because positive for y squared is facing to the right. Okay. That means that my focus is going to be 1/2 unit to the right, and my directrix is going to be 1/2 unit to the left. And my parabola then will be y squared, which faces to the right, and there's my focus, and there's my directrix. Okay. So what does that look like in terms of coordinates? Well, I took my center, I added 1/2 to the x to find the focus, right? And then how did I find the directrix? Well, x equals 3 minus 1/2. And this minus 1/2 is the p, and this 3 is from my center, okay? So I just wanted to do one that included some fractions because I think sometimes those can be intimidating, but they really don't need to be, all right? It was just counting by different amounts on your graph, all right? But all the information is the same. Okay, so let's finish off here with a few examples, 3 examples on finding an equation that satisfies the given condition, okay? Now in this case, the center is not necessarily, or the vertex is not necessarily at the origin, okay? So this time we have to be kind of careful with our drawing. But we can approach it the same way, where we start by sketching a diagram, okay? So my focus is at 2, 0, and my directrix is at -2. Right? So if I were to sketch in my parabola, the vertex has to be halfway between those two. And it turns out that halfway is the origin in this case. All right, and it's going to open this way so that we get our focus inside of our parabola. Now, since it opens side to side, we know this is going to be a y minus k squared equals 4p x minus h. So now we just need to fill in the numbers. Well, y minus 0 squared equals 4 times, wow, we can just look at the diagram to help us find p. So p is from here to here, which is 2. Or you could say p is from here to here, and that's also 2. So we're going to plug in a 2 for p, and then x minus 0. So this equation really is y squared equals 8x. Okay, so that's kind of how you go backwards when you're given some pieces of it and you want to write the equation. All right, let's take a look at number 8. Set up our XY grid. And let's draw in our vertex. So -2, 3. And my directrix is at y is 5. So that's, whoops, that's above that. Okay. Well, if the directrix is above by 2 units, and I just took 5 and I subtracted 2 or 3 and I got 2, okay? So if the directrix is above, well, where is the focus? It better be below. So how far do we go down to find the focus? Well, we go down the same amount. And so if we move 2 more down, we'll get to our focus. And then we can sketch in that parabola. Okay. Now the goal here wasn't to sketch it, we wanted to write the equation. So this one, because it's facing down, is going to be x minus h squared equals 4p y minus k. Remember, there's only 1 squared for the parabola. We don't need a y minus k squared, okay? So let's fill in our center. X plus 2 squared equals, let's see, y minus 3. Okay, so p is just that distance. So 4 times 2 is 8. And we know this parabola faces down, so we better put that minus sign in front, okay? So all the pieces have to fit together. Kind of like when we were doing our polynomial sketches, all those pieces have to fit together, okay? So how do we know it's minus? Well, we look at the picture. It's pointing down, so it's going to be a negative x squared. But if the picture were pointing up, then we would keep it a positive 8, okay? All right. Let's try one more. Set up our grid. All right. My vertex is at 1, negative 2. My focus is at 1, 0. Okay. Well, how far apart are those two? That's a good thing to know because that tells you P. Well, I counted up 2 boxes to get there, all right? Which means that if I wanted to find the directrix, I would count 2 in the other direction, right? So this is also P. And we know that this equation would be y equals negative 4 because I counted down another 2. And you could just sketch in your parabola, okay? But again, what we're really interested in is the equation. So because it's facing up, x minus h squared equals 4p y minus k. Where's that center? X minus 1 squared equals, let's leave a space, and then y plus 2. All right, so if p is 2, then this coefficient is 4 times 2, or 8. And I don't need to make it negative because it's not pointing down, it's pointing up. And there we have it, our equation for the parabola, okay? So when you come to class on Wednesday, bring questions so that we can address those. And we'll go over a couple more practice problems just so we really got it. And I'll see you folks on Wednesday. Have a good day.